This video we are going to discuss about again post-fertilization event, and that is the formation of seed and fruit. Now we have studied that after the process of double fertilization, the ovule is converted into seed. Fertilized ovule is known as seed. And typical seed contains three parts. One is known as seed coat, another one is known as cotyledons, and third one is known as embryo axis. Seed coats are nothing but the protective coverings outside the seed. The cotyledons are generally become thick, become fleshy, become nutritive to provide nutrition to the developing embryo enclosed inside, as for example, leguminous plants. Embryo axis, as we have studied earlier, it contains pleura and ovule. The seeds may be X-albuminous, or they are called non-albuminous. Because the mature seed does not contain albumin or endosperm. That means endosperm is completely utilized during the development or maturation of the seed. And that's why those seeds are known as non-albuminous or X-albuminous. As for example, pea, bean, etc. But albuminous seeds, here a little amount of endosperm is present in the seeds after the maturation of the seed or embryo. And this is the example of well-known maize, castor, etc. But in wheat, that is beetroot and pepper, some part of nucellus, nucellus, it is also a nutritive tissue around embryo sac. Some part of nucellus is also present over and above the endosperm. So in beetroot and pepper, the persistent nucellus, nutritive nucellus is present, and this persistent nucellus is known as perisperm. So when the seed is produced, or the seeds are produced, the seeds become mature, and during maturity the seeds lose water and they become relatively dry. Generally, a mature seed is very much dry as it contains only 10 to 15% of water. And when seeds lose water, at that time the biological activity of the seed becomes reduced. The embryo which is enclosed in the seed becomes less reactive or inactive. The typical condition of seed is termed as seed dormancy. And seed dormancy is nothing but, again, a facultative character of the seeds to increase the viability for a longer time. Now, When fertilization is achieved, after fertilization, the ovary is converted into fruit. See, the ovule is converted into seed and the ovary is converted into fruit. The wall of ovary becomes the wall of fruit, and that is known as pericarp. The wall of fruit or the pericarp is the protective covering of the fruit, and it may be fleshy or it may be dry. If you see orange, if you see mango, the pericarp is fleshy, whereas in groundnuts it is dry. In the formation of fruits, ovary is incorporated. That means ovary is associated in the formation of fruit. But what about the other parts of the flower? After fertilization, the other parts such as calyx, such as corolla, such as androecium, they fall off. But in some of the fruits, that is in the formation of some of the fruits, thalamus is incorporated. Thalamus is used. Thalamus takes part in the formation of fruit. And those fruits are known as false fruits. So false fruits are the fruits in which other floral part other than the ovary is incorporated. Say thalamus. The best known example is cashew nuts, strawberry, apple, etc. These are the examples of false fruits. And the fruits which only develop from the ovary, that is known as true fruits. So after the formation of fruits, we can think that the fruit is a result of fertilization, and fruit always develop from the ovary. Fruit always contains seeds. But have you ever heard about parthenocarpic fruits? No? Okay. The fruits which are produced without fertilization, the fruits which are produced without fertilization are known as parthenocarpic fruits. And these fruits, as we have studied there, fertilization is not achieved, it is not performed. The fruits do not contain seeds at all. The best known example of parthenocarpic fruit is banana. And this parthenocarpic fruits, as they are seedless fruits, they are having much importance in human life. Now, see, the fertilization events, the gamete transfer events, these events do not include the role of water. But when we sow the seed into the soil, water is necessary. So, the seed must be viable enough to germinate. That means after the seeds are produced, the seeds must be stored for a longer time, or it can germinate after days, months or years. Some of the seeds, most of the seeds can be viable after years. But the seeds of some of the plants, they can be viable for shorter time. Yes. Now, again a question develops in our mind that to how many years the seeds can be viable. See, three things are necessary for the germination of seed: proper temperature, sufficient amount of oxygen, and moisture. That means water. These three things are necessary for the germination of seed. But some of the seeds will not germinate up to hundreds of thousands of years, and they can retain their viability up to longer time. As for example, in Arctic tundra, a plant known as Lupinus arcticus. The seeds were found of Lupinus arcticus from Arctic tundra. They were 10,000 years old, and we are having a kind of information that those seeds, after 10,000 years, they germinated and those flowered. The same kind of example is also seen during excavation near the Dead Sea in King Harold's palace. A date palm, the name of the date palm is Phoenix dactylifera. The seeds of the Phoenix dactylifera, they were 2,000 years old, and they also germinated. So this is known as the viability of the seeds, and this is the important characteristics of the seeds. And because of this characteristic only, we can store seeds for a longer time, grains, pulses, etc. Now, what will be the number of seeds in a fruit? We don't know. Some fruits contain a single seed. Some fruit contain large number of seeds. Have you ever heard about orchids? Or orbanki? Or striga? Or ficus? See, orchid, orbanki and striga, they are which kind of parasitic plants? Orchids, ficus means banyan tree. So these fruits are having large number of seeds. And what is the importance of having large number of seeds? These kind of plants can distribute themselves very rapidly up to miles and miles. Right? So this was the end of post-fertilization events, and now we are going to discuss the last topic, and that is Apomixis. What do you mean by Apomixis? See, Apomixis is a kind of reproduction in which seeds are obtained without fertilization. This is the main characteristics of two families, Asteraceae grasses. Seeds are obtained, seeds are produced without fertilization, and that is known as apomixis. So here, reproduction occurs, but no sex is involved. So we can say the apomixis is a kind of asexual reproduction which mimics sexual reproduction. How the apomixis is achieved? There is reasons after these is there. Sometimes egg sac, diploid egg sac is produced without reduction division. Generally, egg cell is haploid in nature, but that is the result of reduction division or meiosis. But here, the diploid egg cell is produced without reduction division, without meiosis. That means it is perfectly diploid in nature. These egg cells, without fertilization, will develop into embryo, will develop into seed again, without fertilization. So this is known as apomixis. Sometimes, in some of the cases, you may observe that the cells of nucellus and nucellus is nothing but the protective structure outside the female gametophyte or embryo sac. But here, the some cells of nucellus, they group together and they protrude inside the female gametophyte, inside the embryo sac, and they will be converted into embryo. See, embryo will be formed from fertilized zygote, but here new embryo is formed from the cells of nucellus which protrude inside the female gametophyte. So here, in a single female gametophyte, in a single seed, in a single embryo cell, we will be able to observe more than one embryo. And this condition is known as polyembryony. And this is quite common in groundnuts, in onion, in mango, in citrus, etc. Now, we have a question that how apomixis is helpful to the farmers. How apomixis will be helpful in obtaining different crops. We know that nowadays hybridization is carried out for different kinds of crop varieties. But what happens? Every time the farmers must buy the hybrid seeds. Why it is so? Because when the seeds are sown into the soil and when flowering occurs, and at that time, if fertilization occurs in those kind of seeds, that means flowers, and as a result, whatever the seeds are produced, the seeds will contain some inbreeding depression characters. So the main characters, the desirable characters of the hybrids will be lost. And so that to protect that, to obtain the desirable characters, every year the farmers must buy hybrid seeds from the market. And hybrid seeds are not cheaper. They are more costly. But if the hybrid plants are apomictic, then apomictic, that means production of seeds without fertilization. So the hybrid seeds, when they are sown into the soil, the crops will be produced, and the crops again without fertilization, they will produce hybrid seeds, and that can prevent the loss of money of farmers in nowadays. So friends, This was the last topic of chapter number 2, standard 12, reproduction.